Implicit differentiation. Now, the types of functions that we were differentiating before were explicit differentiation, were explicit function. For example, y is equal to 3x squared. That's an explicit differentiation, meaning you have y, the dependent variable on one side, clearly separated from x, the independent variable, on the other side. All right? Now, if you have a case where you say x plus y equals 5, that now is an implicit function. It doesn't clearly show x and y separately. But of course, at the same time, with this function, fortunately, what you can do is transpose and get y equals, and then x is over the other side. So, if you want to differentiate this, you could first of all say y equals 5 minus x, and then you differentiate and find dy by dx. Because that's what we want to do. We want to find dy by dx in each case. However, with some functions, it's not so easy to transpose. In fact, some of them are extremely difficult. Transposing them is extremely difficult. And some of them is just impossible to transpose. Alright? So you use the principle of implicit differentiation. So, let's see what we have here. Here, if you have x plus y equals 5, as I said before, you could transpose and say y is equal to 5 minus x, and then you say the derivative of y with respect to x is equal to this part, the derivative of 5 with respect to x, minus the derivative of x with respect to x. So dy by dx equals the derivative of 5 with respect to x. When you differentiate 5, you get 0. Any number, you get 0. Remember, that's based on the power rule. 5 means 5x to the 0. In fact, 5, it means 5 by 1. But if you want to show the x in it, you would say 1 is the same thing as x to the 0. And when you differentiate using the power rule, you're going to multiply by the 0, so you bring down the 0 in front and multiply it and say 0 times 5 x to the, and you subtract 1 from the old power to get the new power. So you have 0 times 5 x to the negative 1. But then 0 times any number gives a 0. So this part is 0. Alright? Minus dx by dx. What is the derivative of x with respect to x? In other words, when you differentiate x with respect to itself, what do you get? Remember the power rule again. When you have x, it means x to the 1, but you don't bother to write the 1. So using the power rule, I write the 1 now and use the power rule. I'm going to bring the 1 down in front of the x and say 1 times x to the, and reduce the old power by 1 to get the new power. It's 1 minus 1. So this becomes 1 times x to the 0. What is x to the 0? It's 1. So what you get is 1 times 1, which is just 1. So you get 1. So dy by dx is a negative 1. So you get negative 1. So the answer, dy by dx is equal to negative 1. Now, Let's look at it again. Let me erase parts of the board first of all. Suppose instead of transposing for y, you did this. You're going to find the derivative of each term with respect to x. So you say dx, the derivative of x with respect to x, plus, and the derivative of y with respect to x equals the derivative of 5 with respect to x. Alright, what would happen here? The derivative of x with respect to x, as we saw earlier, is 1 plus, this is dy by dx, equals d5 by dx, the derivative of 5 with respect to x. We saw earlier that it was 0. When you transpose to make dy by dx the subject, you get 0 minus 1, which is negative 1. So again, we get negative 1. So we get negative 1 when we transpose it to make it an explicit function. And then what we did a while ago was implicit differentiation. We did not transpose it. So what we got was the same answer when we did it implicitly. So this that you see here is implicit differentiation. All right. So we'll continue implicit differentiation, but in another video. I'll see you then.